morning, students. Today, our topic is going to be carbon and its components. Why we study carbon under a separate chapter? Till now, 118 elements are known, right? In the last chapter, previous chapter, metals and non-metals, we studied so many metals. We studied the properties of metals. But why are we studying carbon under a separate chapter? Why? Let me tell you, carbon possess very versatile and unique properties in itself. That is why we study carbon under a separate chapter, right? We all know that carbon is solid in nature, right? It has a solid state. It exists as a solid in nature. Now this solid can be of two types, right? It can be amorphous, it can be crystalline. Now what is the difference between amorphous solids, that is amorphous form of a carbon, and crystalline form of carbon? What are the difference between the two, right? So when the difference is about molecules. In crystalline form of a carbon, the molecules are arranged in a definite pattern. They are arranged in a definite shape. But in amorphous form of a carbon, the molecules are arranged haphazardly. That is, they don't have a long range order. They have a short range order. However, in case of crystalline form of a carbon, the molecules are arranged in a definite pattern. So they have a sharp melting point. That is that when a crystalline form of a carbon is cut, it can give a sharp cleavage. A sharp melting point is obtained. On the other hand, amorphous form of a carbon does not give a sharp cleavage when cut with a knife. So now we can differentiate both of them with the help of examples. Crystalline form of carbon includes graphite, diamond, Buckminster fullerene. On the other hand, amorphous form of carbon, for example, wax, quartz, glass, they all have short range order. However, in case of graphite, in case of diamond, in case of Buckminster fullerene, we have a long range order. That is, we have a structure. So we can say that carbon also differs in its structures. That is why we say that carbon forms a huge variety of compounds. Now, coming to graphite, leaving amorphous form of a carbon aside, we will study in this chapter the difference between graphite and diamond. Now, we all know that graphite, diamond, Buckminster fullerene, three of them are made up of carbon. But why their properties are different? In the last chapter also we studied that graphite is a good conductor of electricity. On the other hand, diamond is not. Diamond is a bad conductor of electricity. Why is that so? Why is that so? Can you think of that? Okay, let me tell you the difference between their structures. The difference between their structures. So, let me tell you by drawing a diagram. Now, we can cater the difference between diamond and graphite. The main difference between the two is the structural difference. In case of diamond, you can see here, let me just draw it once. Now here, you can see this carbon. You can see I made these dots as carbon, and you can see here if I give this carbon as 1, so you can see here that this carbon is bonded to 4 other carbon atoms. That is 1, this is 2, this is 3, and this is 4. And as we all know that carbon has a valency 4. That means that carbon, the combining capacity of carbon is only 4. So it's all the valencies are occupied. So that is why there is no place to move for the electrons, or there is no movement all the valencies of carbon are filled. You can see here that in this structure of diamond, each carbon is bonded to four other carbon atoms. That means there is no movement. And since there is no movement of electrons or holes, so we can say that diamond is a bad conductor of heat and electricity. So you can see here the difference, the diamond. Now, when we talk about the structure of a graphite, the structure of graphite is a layered structure, right? It is a layered structure. Let me just draw it for you people. Okay, it is a layered structure. It is a layered structure. Here you can see this is one sheet and this is the second sheet of graphite. You can see here, you can see this carbon. This carbon is bonded to three other carbon atoms. So here the valency of carbon is left. That means this carbon is bonded to three other carbon atoms in the same sheet, and it is bonded to another carbon atom within the another sheet. Now this electron is free to move within the layer. That means if this carbon is making, this bond is partial bond. Can you see this? Can you see these, students? This bond is a partial bond. Partial bond means it breaks, it bonds. It breaks and it bonds. Okay. So what is happening basically here? The electrons is revolving within the same sheet. That is, the carbon is breaking its bonds and then making its bonds, then and the whole process continues. So here an electron is free to move within the same sheet. That is why we can say that there is a possible movement of electrons, there is a possible movement of holes. That is why we can say that graphite is a very good conductor of electricity and heat. That is why it is used in nuclear reactors, it is used in as a lubricant, it is used in lead pencils. However, diamond is a bad conductor of electricity, but since it is very hard in nature, because it's all the bonds are occupied and it is the hardest substance known. That is why it is used for cutting metals. It is used for it is used in surgical instruments. It is used in cutlery, etc. Right? So, however, both of them, diamond and graphite, they both of them are made up of carbon. Still their properties are so different. It is only because of their structural difference. Here diamond is bonded to four carbon. Here in the structure of diamond, each carbon is bonded to four other carbon atoms. However, in a graphite, the each carbon atom is bonded to three other carbon atoms, and there is a partial bond with the another sheet. It is a layered structure, it is a sheet like structure. Okay, so you can say that both of them are crystalline form of a carbon, but their structural difference made the whole difference between their properties. This is all about diamond and graphite. Now we will study about the versatile nature of carbon. Why carbon is so versatile in nature? It is because of its property of catenation. Now what is catenation? Catenation, it is the self-linking property of carbon to form branch-like structure, to form ring-like structure, to form a cyclic structure that carbon can link with itself. We all know that carbon forms bonds by the sharing of electrons, that is with the help of Covalent, covalent bond, right? What is covalent bond? Covalent bond, the bond which is formed by the sharing of electrons. So carbon also form bond by the sharing of electrons. So it has a unique property which is known as catenation, that is the self-linking property of itself to form different type of structures, right? The second property, very important property of carbon which makes it unique is its tetravalency. Tetravalency and its small size. We all know that carbon has a valency 4. It has 6 electrons in its outermost, the carbon has a in its outermost shell, right? So if it loses all 4 electrons, it will form C4 plus cation, which is impossible, which is highly unstable. Why? Because it requires a lot of energy to remove all 4 electrons, right? On the other hand, if carbon gains 4 electrons to complete its octet, then it will form C4 minus anion, which is also impossible because the small size of carbon cannot accommodate all extra electrons and the molecule will be highly unstable. The repulsion will take place between all the 4 uh, electrons and the electrons which it has gained. So it is impossible for carbon to form C4 plus cation or C4 minus anion. That is why carbon forms its bonds with the help of sharing, right? So it forms very strong bonds and it forms bonds with itself, also with other elements. It can form with oxygen, it can form bond with sulfur, it can form bond with nitrogen. Also, it can form multiple bonds. That is, it can form single bond, it can form double bond, it can form triple bonds. How? By with the help of sharing. If it shares one electrons with the another element, then it forms single bond. If it shares two electrons with another element or with itself, it forms double bond. If it is sharing three electrons with itself or with other electrons or with other elements, then it forms triple bond. So this is the unique property, we can say, this is the unique property of carbon through which we can justify that carbon is versatile in nature, and that is why it is able to form more than 500 million